Exercise 3, the adjacent figure represents the position time graph of a moving object that describes a rectilinear trajectory. Yani this object is moving on a straight line. As you can see for V versus T, it is divided into two phases. Phase 1, in which the car was accelerating its speed, لأنه V versus T is an increasing straight line. In the second phase, it remained moving at the same speed. So specify the nature of motion during each phase. For phase 1, it is a uniformly accelerated rectilinear motion since the graph of V versus time is an increasing straight line. Phase 2, uniformly rectilinear motion, URM, since the graph of V versus T is a horizontal line showing that the speed is constant. Determine the position-time equation of the object during the second phase, knowing that at t equal 20 seconds, it reached a position of x equal 400 meters with respect to the origin of reference. So, for the second phase, which is URM, it started from a position from a position قالوا لنا x equal 400 meters away from the origin. يعني while studying phase 2, it did not start from the origin. In phase 1, it started moving from the origin. From phase 2, can start away from the origin by a distance equal 400 meters. So we consider that the initial position of the car in phase 2 with respect to the origin is 400 meters, not 0. And the initial speed is given from the graph. It started at t equal 20 seconds. يعني this corresponds to a speed of 30 meters per second. So this is the initial time for this phase, and this is the initial speed for this phase. URM, whether URM is x equal vt plus x0. هلا بالURM it doesn't differ the initial from the second from the first speed لأنه it is constant. So x equal vt plus x0. Substituting, we are given x0 and v in the SI unit, so we simply substitute x equal 30t plus 400, where x is in meter and t is in seconds. Calculate the average acceleration during each phase. In the first phase, the average acceleration, يعني we have to consider the initial instant of this phase and its final instant. The initial instant at t equal 0. Final instant at t equal 20 seconds. The difference in the speed is 30 minus 10, يعني the final one minus the initial, over the final instant minus the initial instant. All in the SI unit, 30 minus 10 over 20 minus 0. 20 meter per second over 20 seconds is 1 meter per second square. While for the second phase, as long as we know that it is URM, then it is going to be 0, لأنه there is no acceleration in the URM. And if we do the calculations trying to find the difference in the speed over the difference in the time, we're going to find that the speed at the final instant of this phase is 30, and the speed at the initial instant of this phase is also 30. So 30 minus 30 is 0, and 0 over time is going to be 0. So in the second phase, A is 0 meter per second squared, since delta V is 0 meter per second in the URM. 4, deduce the position time equation during the first phase, knowing that at t equals 0 seconds, it started moving from the origin of the frame of reference. يعني for the first phase, they are telling us that it started moving from the origin. يعني x0, or the initial position, is x0 equal 0. We know that it is moving in UARM. And we know that the general formula for the position time equation is x equal half at squared plus v0t plus x0. A is calculated in the previous part 3. V0 could be taken from the graph, which is, this is the initial speed at t equals 0. It is 10 meter per second. And x0 is given to be 0, لأنه they said that it started from the origin. Substituting, we get that x equal half t squared plus 10t. Now calculate the total distance covered by the object during the 80 seconds. During the 80 seconds, يعني during the two phases, phase 1 plus phase 2. Of course, we cannot just simply divide the speed by the time in this case. We have to divide our work, in which we calculate the distance covered by the car in the first phase and that by the car in the second phase. Using the time equations in the first phase, x equal half at squared plus v0t plus x0. We are concerned with the distance between the final instant of the phase and the initial instant.